Okay, so the 19th problem in the lead code is to remove the nth node from the end of the linked list. Okay, end of the list. So we will be given a linked list here, and it's a single linked list, so we can traverse in only one direction. Okay, and we are asked to remove a node. Okay, the condition is it is not from the start; it's from the end, basically. Okay, and we won't be given the length of the node that is there. Okay, and let's say that if they're given the like I mean if we are asked to remove a node from the starting, right, let's say that remove the second node from the beginning, we could use the incrementer pointer, and then we'll increment, and we could remove that point. Okay, that was the easy case. Now the thing is we are asked to remove the node from the back. Okay, so and also we know that we can traverse only this way, we cannot traverse back. So just by assumption, like let's say that we by just by traversing, right, there are multiple ways actually. So what one way could use here is, let's say that if you use a single pointer, right, let's say it is like a multiple iteration we need to do, correct, like once we might go here, go till end, and also we will find the length, and then iterate back again and go to that node and remove that node, right. This is like it increases a bit of complexity, correct. It's not a open, it will be like I mean so what we can do now is instead we can use a two pointer approach, right. So what we'll do is, okay, this is it, let me just undo my changes. Okay, so now what we'll do is, let's say that we are on a race. Okay, we are on a race, we have we have one single person. The condition was to go from here to the end, and also he will have to pick some element in between. Okay, and the condition is you shouldn't be coming back. The only thing is you will have to go in this way, in direction, this direction. Okay, so now what we can do is, let's say that we have instead of one person we have a two person. Okay, now let's call him x and y. Okay, and let's say that if you have a 2%, let's see how to do it. Okay, and every time that walks it, they will be taking a step, like one single step. Okay, so let's say that now as we know that if you it can be traversed in only one direction, we cannot step back. What we'll do is we'll make use of these two persons, and in such a way that we are told that, like I mean let's say that we will there is some treasure or something from the some n number of steps from the end. Okay, so let's say that if n is equal to 2, like I mean it means that this is the one we are need to supposed to remove. If n is equal to 3, we are supposed to remove this. Okay, like looking at this, what we can do is, like if we somehow identify, like when traversing, if you are somehow identify that this is what we are trying to pick up, right, there, then we are good, correct. So how we are going to achieve it is, let's say that I will keep my person here x, and what we'll do is we'll set some person y to the like forward, like we this will be the slow person, and we'll keep in the like keep another person in the forward. Actually, like I mean the racetrack, we'll keep it somewhere in the forward, so that when he reaches the end, he will we'll get to know that that is the end, and we can pick that element. So let's directly jump on to this basically. So let's say that n is equal to we'll have to pick this up. Okay, we'll have to pick the this one, or let's say this one. Okay, we'll have to pick the third element from the last. Okay, so now what we'll do is we'll pick the two persons here, we'll set the slow person here itself, and we'll make our fast person to jump to the by the three position, whatever the position is here, right, whatever the position we need to pick, we'll jump that person to the three step. Okay, 1 2 3, we'll be placing our y person here. Okay, so now what will happen is we will be asked to, like in each iteration, this each like x and y will take a step. Okay, at the end what will happen, once this y reaches the to the end, we will know we have reached the end, correct, it will reach the end. So that x can read that value, and it can understand that we are at the end of the list, y reached the end of the list. So it means that the next whatever the position is there, right, that is the spot we are supposed to remove that from the list. Okay, so now let's just see how it looks. Okay, let's say that we have placed our y. Okay, like based on the n is equal to 3, we have placed our y. So now let's take a step. Like, okay, this will he will also take a step, he will also take a step, and he will also take a step, he will also take a step, and take a step, and take a step. Okay, we were here actually, and now, right, when we came to this part, and it should be reading the value basically, like what is the next value for y, right, like so when the y is here, it means that y dot next, right, whatever the value it is none, it means that y has reached the end of the racetrack. Okay, so it means that, like as we have, like there is the same difference, right, the same difference this and this guys had. So now it means that whatever the next element s also, it is the it is the position it needs to remove. Like just like y has reached the end of the list, similarly s has reached that spot where that element needs to be removed. So similarly what we'll have to do is the next logic will be kicking. Okay, we identified what is the element that we needs to be removed here, so we'll remove this by pointing the slope pointer to directly to this, and we will be returning the head node. That is the logic about this. Is a, like, I mean, for slope pointer and fast pointer. And coming back to, there is one edge case actually. Let's say that we are asked to remove the head node itself. Okay, this is the head node, and this, okay. And let's say in this track there are four nodes. Okay, like what will be the, if you want to remove the head node, like that will be n is equal to 4, correct? So in this case what will happen is, how will we identify, correct? So let's say that if what is our logic? Let's say that we need to have two pointers basically, right? Slope pointer and fast pointer. So when is equal to 4, I will move my pointer to 1 2 3 4. We have already reached to none. Okay, like let's say that if n is always less than, if whatever the n, right, if it is less than the number of items, n will always have some value. As we can see here, we stopped our pointer here, and n had, like, I mean, y had some values. But when we are planning to remove the head itself, it always leads us to the none actually, right? Like, I mean, whatever the second pointer, it is already landing onto a none. So what we'll do is, like, after we making the y jump to some position in the initial step, once if the y itself is a none, it means that head needs to be removed. So what we'll do is, we'll just return the head dot next. Like head is this, we'll remove the, we'll take the head dot next, so that head will be removed from the list. Okay, like just looking at the code now, what we'll do is, we'll initially set the slow and fast pointer to this location, and then we'll make the fast pointer jump to some location based on the n, how many points we need to make a difference, right, between the slow and fast. Let's say that n is equal to 2, we will say y will be jumped twice, this. Okay, we'll y will be fast pointer will be here, slow pointer will be here, and then we'll start incrementing. F has some value here, right? F has some value here, correct? It is not an empty, so we'll not return this point. This is an edge case, will not go there. And then till the point where the first pointer has nothing, right? In the next, if it is reaches the end, we will stop there. Like, I mean, we'll incremented, we incremented. By the time they reach, if the slow pointer will be pointing to this, fast pointer will be pointing to this. Okay, and what is then our and the main task is, we'll have to remove that, the node next to the slow pointer. We'll be pointing our pointer to directly to this is it, and then we'll return the head. And if it was a case, it's one element, right? We only have one element, and we are asked to remove it. We are asked to remove the head node. Okay, we are asked to remove the head node. In that case, we will be falling into this logic. Yeah, that's it. Thank you.